Hey guys, welcome back. Today we're going to learn about relations and functions. Okay, so in the past, you have learned about relations. They can be represented in 4 different ways. Okay, the first way is a mapping. Okay, M-A-P-P-I-N-G. Okay, so in a mapping, your input is on the left and your output is on the right. So if I wanted to take this mapping and come up with an ordered pair, the input would be 0, the output would be 2. I'd have an input of 0 and an output of 3, an input of 5, an output of 4, and an input of 10 and an output of 5. Okay, so that's how a mapping works. The second way is with tables. We should be familiar with that. So on the left we have our inputs, and on the right we have our outputs. Okay, so if we had taken the table here and put it in an ordered pair, it would be an input of 0, output of 0. We'd have 1, 2, 4, 8, and 6, 12. Okay, the third way, we have our ordered pairs that we've been talking about. So we should have been pretty familiar with ordered pairs. In this case, our x is the input and our y value is our output. It's always in the form x and then y. And then the fourth way would be by graphs. Okay, so we can take those ordered pairs and we can then graph them with the x-axis and then the y-axis. So if I took the point, in this case it would be 1, 0, would be right here. You just count over 1 and then up or down 0. So that's how we get 1, 0. So you can take all of the points from the graph. Okay, so a function is a special type of relation in which each x value has only one y value. So if we look at the mapping right here, our inputs are our x values are 2, 4, 6, and 8. And notice 2 only has one output. It goes to 3. 4 goes to 5. 6 goes to 7. 8 goes to 9. So those all have one output, so it would be considered a function. Okay, if my 2 also went to 5 like this, it would not be a function. Okay, that's an example of not a function, but because every single input only has one output, it is considered a function. Number 2, our 0 looks okay, but then our 1, if you notice, 1 goes over to 5, and 1 also has an output to 8. So it is not a function, and the reason why is because 1 has 2 different outputs. Okay, if we looked at the table in number 3, our inputs are listed as 1, 2, 3, 4, and 5. And they're all different. Even though they share some of the same outputs, our inputs are all going to one. Each input has only one output, so it is a function. Okay. And number 4 is a little tricky because at first glance you think, well, inputs are 1, 1, 2, 3, 4. So these 2 1s, if you notice though, they both go to the same output. So that's okay. So it is a function. Okay, so in that case, each x, let's write this in, each x has only one y value. Okay, if we looked at number 5, we have a set of ordered pairs. Well, it is, in this case, it would be a function. We just look at our x values. We've got 4, 0, 1, and 7. They're all different, so yes, it's going to be a function. All right, but if you look at number 6, we've got 5, 2, negative 2, 15. We've got negative 7, 15, and then we also have a negative 7, 2. So that would not be a function, and that's because negative 7 has 2 different outputs. Okay. All right. Now we can look, we can determine if a graph is a function. We can use the vertical line test. Okay, it's called the vertical line test, V-E-R-T-I-C-L, vertical line test. Now remember, a vertical line goes up and down like this. Okay, so the vertical line test. So if I was looking at number 7, if I had each of these points and I made a straight line, vertical line through each of those points, would I ever cross another point? No, so I can call that a function. Okay, if I ever cross 2 points, then it would not be a function. So in this case, if I look here, I'm not going through, I only go through 1, 1, 1, up, but right here, see how I cross 2 points? So no, that's not a function. Does not pass the vertical line test. And number 9, well, I can draw an infinite number of vertical lines. I'm never going to cross more than 1 point. So number 9 would be considered a function. So if a vertical line passes through more than 1 point, it is not a function. Okay, so we can use that vertical line test to help us see if it's a function. So looking at these, number 10, okay, if you notice, this little curve here is approaching the y-axis and the x-axis, but it's never ever hitting it, but it's getting just a smidge closer each time. Therefore, you can never draw a line and go through 2 points, so it is not a function. Okay, number 11, well, it's a vertical line, so of course we can go through an infinite number of points when we draw a vertical line, so that would not be a function. Okay, I'm sorry, going back to number 10. 10, I made a mistake there. It passed the vertical line test, so it is a function, okay? If you notice, we can never go through it. I don't know why I wrote that down. So I can never go through more than 1 point, so this would be a function right here, yes. Okay. Now looking at number 12, as soon as I make a vertical line, I go through 2 points right there, I know it's not going to be a function, okay? All right, so let's introduce some new vocabulary. We have vocabulary domain and range. The domain is the set of all of the inputs or the x values. So let's write x values slash inputs of a function, okay, or of a relation. Doesn't have to be a function. Okay, x values are the inputs. Okay, the range is the set of all outputs. So the y values, the y values, and it would be the outputs. Okay, so think of this also as the x values are your independent variables and your y values are your dependent variables. Okay, we gave you this little acronym to maybe help you, ZIDROI. X stands for your x values, I stands for your input values, and the D is your domain. Okay, ROI, we've got the range for your output. Okay, the O is your output values. Okay, still like that, output, and then your y y values would be your y. Okay, I kind of find that's a little difficult to understand, so I have my own little one I use. It's Dr. XY. All right, Dr. XY, the algebra guy. All it does is help me with domain is your x values, range is your y values, and then from there you should know your x values, your input, your y values are your output. Okay. So if we looked at the information provided to determine the domain and range of each relation, then decide whether each relation is a function, we're going to start out and identify the domain. Okay, so the domain for number 13, I'm going to run out of space here, would just be the 3 input values, and it would be in a bracket, enclosed in a bracket, 0, 5, and 10. That would be your domain values. And your range would be 2, 3, 4, and 5. Okay. All right, so we have our domain and we have our range. Okay, we're not going to duplicate any data values, and we're going to put our data values in ascending order, starting least to greatest. Okay, if I look at those two, is that relation a function? It would not be, because if you look at it, our 0 is actually going to 2 different outputs, 2 and 3. So number 13 would be no, it's not a function. Okay, 14. If we listed our domain would be all of the x values, 0, 1, 4, and 6, comma, 4 and 6, and our range would be all of our y values, which would be 0, 2, 8, and 12. Okay, and if we look at that, we have an input, we've got the input 4 going to 8, all right, and then we have the input of 6 going to 12. So if we look at that, it would be nothing is duplicated from our input, so it would be a function. So let's write yes. Okay, and then the last mapping, our domain would be we're going to list them as 1, 2, 3, 4. And our range would be 0, 1, and 2. Okay, but our input is not repeating, so it would be a function. All right, now looking at 16, our side table here, input of 2 goes to 0 and input of 2 goes to 1. So this is not a function. Okay, but our domain, if we list it, would be 2, 4, and 7. Remember, we're not going to repeat the input values. And then the outputs, or the range, would be 0, 1, 2, and 3. And again, it is not a function. Okay, so functions can be listed, let's see, functions can be represented by equations, okay? And we have a certain notation we use. So if I have a function f and then I have this parentheses x, we're not multiplying, we're actually reading f of x. It's called f of x. So in this case, y is equal to 2x minus 3 is the same as f of x is equal to 2x minus 3. All right, and I can differentiate my functions by just the letter at the beginning. So I could have a function f of x, but I could also have a function g of x. And g of x might be something like x plus 4. Or maybe I have an h of x, okay? H of x, maybe I'll have that be 3x minus 1. Okay, so there I have 3 different functions. And if I asked, okay, what is f of 4 equal to? What that means is I would use 4 as my input for my x value, and this would be, all I would have to do is say 2 times 4 minus 3, which is 8 minus 3, which is 5. So f of 4 would be 5. So we could write that as an ordered pair 4, 5, okay? Just like I could say, well, what's g of 1? Well, g of 1, I just plug in 1, and I get 1 plus 4, and that would be equal to 5. Okay, so that's how I read my functions, okay? It's f of x, g of x, h of x, okay? But remember, all right, notice the function only works when the output is the same for the given input, okay? So if I'm looking at a function table for each of these, okay, notice here we have f of x is equal to x minus 4. So that's our rule right here that we have in the middle. The x values are our inputs and our y values are our outputs. So I'm going to take that x value, -1, and I'm going to plug it in for my x. -1 minus 4 is actually equal to -5. Okay, so I can write that as an ordered pair. -1 input, -5 output. And then I can graph it. -1, -5. 1, 2, 3, 4, 5. Okay. I'm going to put in the 0 minus 4, and I get -4. So my input has a 0, my output has a -4. Again, I can graph it. 0, and then I count down 1, 2, 3, 4. All right. 1 minus 4 would be equal to -3. Okay, and that would be a positive 1, sorry. Positive 1 is my input. Oops, let's get rid of that. Okay, so we have positive 1, and then we have an output of -3. So it would look like this. Point right there. Okay, 2 minus 4 would be a -2. Input of 2, output of -2. So I got my 2, 2. Okay, and then the final one, 3 minus 4, would give me a -1. So if I have an input of 3, I have an output of -1. 2, 3, -1. Okay, so notice right here I have discrete points here. Okay, in that case, my range, my domain rather, okay, would just be the points. All right, we'll list them. -1, 0, 1, 2, 3. Okay, running out of space here. But watch what happens if I actually connect these. And in this case, too, my range would be the values -5, -4, -3, 2, and 1. Okay, individual points like that. Okay, but if I connected these points and made them continuous like this, okay, and made a line, my domain would be different. Actually, it changes. So my domain would be all real numbers because that line goes on and on forever. And my range would also be all real numbers. Okay, so be careful to note the difference between when you have individual points and when the points are connected and a line is made out of it. Okay, for purposes of time, I'm going to stop this video right here and have you guys try the other functions and compare it to the answer key online. The only thing I want to note is, let's see, the last one that we have, Nope, I think we can do the rest of them online. So just go back to the answer key and take a look at them. Okay, bye-bye.